In this video, I am going to give you an introduction to design systems. A distributed system is often used when there is a large amount of data to handle efficiently. There are some terms and components that you should know. There are two ways to scale a system, horizontally and vertically. Scaling vertically means that you add more CPU and memory to your machines. The pros of this technique are that it reduces the latency and data loss rate since everything stays in the same machine. The con is that if the machine fails, you lose everything. Scaling horizontally means that you add more machines. This is best when you are handling thousands of queries per second. The pros are that if one machine fails, another will take over. You can have a limited amount of data. If you have more data coming, you add a new machine. The cons are it will add latency, and there are more chances of losing data since it will go through the network. Now let's discuss latency and throughput. Latency is the time to perform some action or to produce some result, while throughput is the number of such activities or result per time of unit. Generally, it will help if you aimed for maximal throughput with acceptable latency. CEP theorem. You should know the CEP theorem, as it will help you design your system. C stands for consistency, A for availability, and P for partition tolerance. Consistency means that the system receives the most recent write or an error. This is very important for systems such as messaging apps, where you want the messages to arrive in the correct order, or for a banking app, where you want to ensure that the transactions are correctly processed. Availability means that every request receives a response without guaranteeing it contains the most recent version of the information. This is true for a timeline of a social media platform, where it is more important to see something in the timeline rather than wait a few minutes to get the last post. Partition tolerance means that the system continues to operate despite network failures. All systems must be partition tolerant, as they always expect network failure to happen. The trade-off should be between consistency and availability. If you want your system to be consistent, you will have some latency in retrieving the exact data you are requesting in your system. On the other hand, if you want your system to be available, you should retrieve the data as fast as possible. Therefore, you may not have the last writes. So you should choose depending on the system priorities. DNS servers translate requests for names into IPs, addresses, controlling which server and end user will reach when they type a domain name into their web server. These requests are called queries. Content delivery network. You can see content delivery network. Content Delivery Network, or CDN. You can see Content Delivery Network has many caches distributed worldwide. The goal is to store files such as HTML, photos, and videos to improve the performance of your system by sending data requested by a user from the closest CDN and reduce the number of requests to your system as they will be taken into account by the closest CDN. Load balancer. A load balancer is a service that distributes client requests to different backend servers. It is used to prevent overloading a single backend server, prevent requests from going to unhealthy servers, helping to eliminate a single point of failure. The load balancer can use different methods to choose which server will receive the request, such as random, least loaded, or round robin, for example. Okay, now let's discuss databases. One crucial decision you must make when designing your system is what database you should use. You will always need a database to solve and manipulate your service metadata. The big question is SQL or NoSQL. You need to choose SQL when you can structure your data into tables. Another possibility is when your tables are related and you need to apply joins. And another possibility would be when you need a fast search, as you can index your tables. You would choose NoSQL depending on your service. You can use a key value store, which would be used when the data is very simple or you need a database that goes very fast. Complexity for reads and writes are done in constant time. A good place to use key value storage would be for a system that handles videos, for example, has Netflix, or pictures has Pinterest, where you can use a unique ID for the key, and the value will be the URL of the item, whether it is a video or a photo. Another type of NoSQL is document store. Document stores can be used when you need to store documents like data, JSON, XML, binary, and so on. It can be used when we need to keep structured or unstructured data types with very few relations. Document store is ideal for storing loads of documents that can be stored by tag or category. You can use a document store for an e-commerce-like system where the data would contain product information. Another type of NoSQL is graph database. A graph database comprises nodes containing some data, and each arc is the relationship between two nodes. Graph databases offer high performance for data models with complex relationships. Graph databases are good for social networks like Facebook, LinkedIn, and Twitter, for example, but they are also suitable for maps systems such as Google Maps, Waze, and so on. When storing data, it is essential to put in place a system that can be fault tolerant. So if a server fails, it is necessary to be still able to retrieve the last data stored. There are different methods to handle this situation. So let's first review master-slave replication. Master-slave replication is when there is a primary storage that will handle read and writes from the clients. The master storage will duplicate the data into the slave storage, and the other clients can read from the slave storage. If the master fails, then a new master will be elected. Another type of replication is master to master. In master-master replication, both storage can handle reads and writes from clients and coordinate each other on writes. If one of the master goes down, the survivor master will take all the reads and writes. Sharding. Sharding is a way to partition the data between different databases. Each database will handle a subset of the data. The advantage of sharding is that we end up with less read and write replication and more cache hits. If one shard goes down, the other shard will still be operational, even though it is important to add replication to avoid data loss. Cache. A cache saves the data that is frequently accessed in memory. Accessing data from the cache is always faster than accessing it from the hard drive. In addition, it reduces application latency because it has all the frequently accessed data. You need to cache the metadata in almost all distributed systems to access the most used data faster. Message queues. A message queue is a form of asynchronous communication. It stores data in a queue while the application is processing the previous data stored. Each message is processed only once by a single consumer. Message queues can be used in messaging apps or financial systems. Okay, now that we reviewed the most important components of a distributed system, let's talk about the methodology to resolve the distributed design system interview successfully. First, clarify the requirements by asking questions. Same as for coding question, you must understand the requirement well. Design questions are mostly open-ended and they don't have one correct answer. It would be best if you asked as many questions as possible. You should start with the functional aspect of your system. If the interviewer asks you to design YouTube, the question that you may want to ask would be, what functionalities do we want to focus on? Video upload, channels, subscriber, comments? How many videos should our system handle? How many views would we have per day? What would be the average size of a video that can be uploaded? Do we want to handle thumbnails? The second thing that you need to focus on is the non-functional requirements. According to the interviewer's answers, you can start talking about the non-functional aspects. For example, you should decide if your system should be more available or more consistent. Obviously, you need to be able to justify your answer. The final part of the clarification is to do some calculations to know the scale of your system. You should calculate the following: number of requests per second, ratio of read against writes, storage necessary in the short and long term. Those calculations will guide you on how you should scale your design, like sharding, caching, replicating. Second, discuss your choice of database. Now that you understand the requirements well, you need to assess if you should use SQL or NoSQL. Once again, you should justify using one rather than the other. If you decide to use SQL, you might need to write down your tables and the relations that they have between each other. Third, design a high-level system. Draw a diagram representing the core components of your system. Start small, as if you had only 2-3 users, and make sure that your design resolves all the use cases that you defined in the first part of the interview. That is what you would do in the real world anyway. Then you would start creating a system for a few users, and once you see that it is working fine, you will scale to handle more users and use case. 4, scale. Once you have your base, then you should scale. Use the calculations that you did previously to decide what subsystems you would need to scale. What part of your system do you need to focus on? Also, you can look at this interview as a brainstorming session. And your interviewer will ask you questions, make suggestions. So listen to what the interviewer tells you and try to work with them. Finally, look and fix bottlenecks. Take a second to look at your design and find the places you would need to improve. For example, can you add a cache to reduce the latency? Do you need to add a message queue to handle messages asynchronously? Do you need to replicate your databases to avoid losing your data if the storage goes down? Okay, so that's it for now. Let's keep going.